The quantitative unification of the three standard model gauge couplings at the grand unification scale is one of the cornerstones of the gut paradigm. Gauge coupling unification is well understood in the framework of effective field theory, EFT. In the simplest case, the relevant EFT at energies higher than the grand unification scale has a unified gauge symmetry and a single running gauge coupling. The EFT has three independent couplings and the standard model, or supersymmetric standard model, matter content. One-loop renormalization group equations readily allow for an extrapolation to the weak scale. Here we defined delta to absorb all subleading effects, such as threshold corrections at or near the weak scale and at the grand unification scale, and also higher order corrections. It is apparent from the equation that the three low-scale couplings can be very different. This is due to the large energy range between the Z boson mass and the grand unification scale and the non-universal beta function coefficients. Incomplete gut multiplets, such as gauge and Higgs bosons in the standard model and also their superpartners and the additional Higgs bosons in the minimal supersymmetric standard model, contribute to the differences between the beta functions. Inverting the argument, one expects that extrapolating the measured couplings to the high scale, we find quantitative unification at the grand unification scale. While this fails in the standard model, it works intriguingly well in the minimal supersymmetric standard model. For non-supersymmetric guts or guts with a very high supersymmetric breaking scale to fit the data, new light states in incomplete gut multiplets or multiple gut breaking scales are required. For example, non-supersymmetric models SO10 goes to SU4 color cross SU2 left-handed cross SU2 right-handed with the second breaking scale of order an intermediate scale, determined by light neutrino masses using the seesaw mechanism, can fit the low energy data for gauge couplings and at the same time survive nucleon decay bounds.